Hey everybody, Mr. Smith here. In this video, we're going to talk about solving polynomial functions. So in the last video, we talked about factoring, and now we are on to solving. So we'll talk about what that means and how we do it. In the last video, we talked about how to factor a polynomial. Okay, so we had problems that look kind of like this. It would say, given that this thing is a factor, we want to factor this polynomial completely. Okay, so we're going to start this problem and eventually solve this thing, but first we got to start by factoring it. Okay, so this is kind of similar to what we did in the last video. So given that this thing's a factor, remember that means that this x minus 1 should divide evenly into this big polynomial. So we're going to start the process by dividing these things using synthetic division. So I look at the number, I flip it. My coefficients, I'm not missing any terms, so it's 2, 3, negative 17, and 12, and now we're just going to do synthetic division. Drop that, multiply, add, multiply, add, multiply, add. I get 0, which makes sense. That should be my remainder, right? Since this thing is a factor, that makes total sense because I should not have a remainder, so it works. All right, so if I factor this thing, it ends up being 2x squared plus 5x minus 12. Remember, I know it's x squared because I started with a cubic, and I just bump it down 1, times x minus 1, which is the factor that I was given at the beginning of this problem. Okay. Remember, from here, we want to factor it completely. So now we want to ask ourselves, does this quadratic factor anymore? Can I factor that thing? Well, let's think about that. Let's do that over here. 2x squared plus 5x minus 12. We're going to see if we can factor this. So there's no GCFs. I can't pull out anything. I'm going to do a times c. That's negative 24. I need two numbers that multiply to negative 24 and add to 5. So we could do 8 and negative 3. That would work for us, so we got to go do the grouping thing. 2x squared plus 8x minus 3x minus 12. We have to do the grouping process because my leading coefficient is something other than 1. So now I'm going to split these up into two parts. Take GCF out of each part. I could take a 2x out of that first part. It would leave me with x plus 4. Remember, I want this to match x plus 4 in the end, so I need to divide out a negative 3. X plus 4 inside there. So now my factored form is the repeated factor times the two GCFs, 2x minus 3. Okay, so if I come back over here now, this thing, 2x squared plus 5x minus 12, just factored to become x plus 4 times 2x minus 3. And then I can't forget about x plus 1, right? The factor that I had there at the beginning as well. So the final factored form of this polynomial is right here, okay? So that, like I said, was what the last video was about. So we just factored that thing. Now let's talk about how we would go and solve this, all right? So now that we factored it, we're going to solve it, all right? So it factored to become 2x minus 3 times x plus 4 times x minus 1. And now we've got this equals 0 part on the end. Okay? So if you remember, back when we were factoring and solving quadratics, the trick was we said that once you get to this point, after you factored, all you need to do is take each factor, set them equal to 0 individually, and solve. It's going to be the exact same thing here. Okay? So no new tricks, no gimmicks. I'm just going to take all my pieces, set them all equal to 0, and solve them for x. And that's how I solve. Okay? Because remember, solving is all about finding the x-intercept or getting x alone. So I'm going to take each of these pieces, set them all equal to 0 individually, and then solve them each for x. Okay? So this one, I got to add 3. I get 2x equals 3, divide by 2, and I get x equals 3 over 2. So there's one of my x-intercepts. On this one, so negative 4, I get x equals negative 4. And over here, I add 1, and I get x equals 1. Okay, so these are my three solutions right here, 1, 2, and 3. I have 3 solutions. All right, so the only new thing with solving is that after you factor, all you need to do is take all your pieces, all of your individual factors, set them equal to 0, solve them for x. Okay, that's the only new piece. So let's talk about, let's see. Let's say you have a problem that's worded like this. It says find the zeros. Okay. Well, remember, zeros, that's another word for x-intercepts or solutions or roots. All those things mean the same thing. Okay. So all this is telling you to do, if it says find the zeros, all that's telling you to do is solve it. Okay, so you don't need to overthink it. If it tells you to find the zeros, that just means to solve it. All right, so I'm not going to do this problem for sake of time, but you would do it the exact same way we did the other one. Okay, you would factor it down. You might need to start by doing the division, right? So you'd start by doing synthetic division. You'd factor it down all the way, and then you'd set all your factors equal to 0 and solve them for x. So I just wanted to point out that if it says find the zeros, that's just a fancy way of saying go solve this thing. Okay. Let's look at one more type of problem, and that's going to wrap it up for this video. Say we got a problem that looks like this. So it says find the zeros. Again, that just means we're going to solve this thing. That's what that means. So we're going to solve this given that x minus 4 is a 0. So that means that x equals -4 is a solution, right? So we've already been given one of our solutions. So we can get this started the exact same way we would in the other problems if we were given a factor. We can just start by dividing. Except this time I'm just going to take the number that it gives me, right? I don't need to flip anything. Instead of giving me a factor like this, it's just given me the solution already. So I can get started just by dividing by this number. -4. Get my coefficients, that's 1, 4, 9, 36. So we can get rolling here. Multiply, add, multiply, add, and multiply, and add, and I get 0. Okay, that makes sense because this thing is a 0, meaning it's a solution, right? So it should divide evenly, all right? So remember, this was a 3rd degree to start. So it's going to bump down 1 degree. It's going to be 1x squared plus 9. So I've got some zeros in here. That's fine. That just means I'm missing a single x term. So this divides into x squared plus 9. Okay. Now, once I get down to here, remember the goal is I'm trying to solve. I'm trying to solve for x. So I'm looking at this thing right here. I'll set it equal to 0, and I say I want to try to solve that somehow. Okay. Well, remember, we can factor, we can complete the square, we can use quadratic formula. Or in this case, what might be easiest is just solving with square roots. I could get the thing being squared alone and then take a square root. So what if I subtract 9? I'd have x squared equals -9. I could take a square root of both sides, right? And I would end up with x equals plus or minus 3i, right? Because the square root of 9 is 3, and anytime I have that negative sign, that's got to give me an I. And I also can't forget about the plus minus. Okay, so here's some of my solutions right there, right? Those are some solutions to this equation. There's one more that I can't forget about, though, right? I was told at the very beginning that -4 is a solution. So all of the solutions to this equation, I have x equals -4, right? So that one was given to me. And I have x equals what I found over here, plus or minus 3i. So these are all of my solutions to this polynomial equation. Okay. All right, so I know that might be kind of convoluted. Basically, the main things you need to take away from this video are that to solve a polynomial, you want to factor it as much as you possibly can, okay? And then if it factors all the way, set them all equal to 0 and solve it, just like you normally would for factoring. If you get something that looks like this, you might have to do square roots, you might have to do quad formula, you might have to complete the square. whatever we can do to solve the rest of that equation. Okay? All right, so this is the last video that I'm going to be making for you guys before we come back to school, so congratulations if you are still watching. But my wife and I are looking for spring break plans, so email me a suggestion, okay? Email me and say, hey, Mr. Smith, if I was you, I would go to here for spring break or whatever. Email me your suggestion. What do you think I should do for spring break, okay? And I'll see you guys in class next time.